Good evening, everybody. This is Cathexis, and tonight I have, once again, Quantum Eraser, and we're going to be going over a couple ideas that we've been throwing around, trying to make a distinction between what science is and what we've all been kind of perceiving as scientism. And, I've never seen so many people triggered by using one word, though. Go walk around to some of your college educated friends and say the word scientism and watch how they behave. It's kind of funny. But yeah, so tonight I want to go through and just kind of make these clarification. John here, he has an excellent presentation where he's going to break down the scientific method and explain why this distinction needs to be made, because there is a lot of fields of science out there that are being called science today that aren't technically science by virtue that they cannot follow the scientific method. So we'll just jump right in. John, how you doing tonight, man?
Good. How's everyone doing out there?
Yeah, we got a pretty good crowd. Everybody, thanks for showing up. Before we go forward with what you have planned there, John, I want to go over kind of my perspective on this and why I'm choosing to talk about this. The definition of scientism is it's amorphous. A lot of people don't really know exactly how to put it. For me, I think some of the definitions of Wikipedia are just fine. This is one that really stands out to me. The belief that the methods of natural science, or the categories and things recognized in natural science, form the only proper elements in any philosophical inquiry, or that science and only science describes the world as it is in itself, independent of perspective. So the scientific method is based off of the rational materialist framework, the philosophical axioms that materialism have set forth to choose their scientific method. And there is a tremendous benefit in doing that. The fact that we are where we are technologically has a lot to do with our lowercase s hard-nosed science. And I think that a lot of critics of scientism get this, people end up getting frustrated. When you say the word scientism, they think you're attacking science. And they don't understand that there is some type of distinction. Even my little brother, one time, I mentioned the word, I was visiting him and I mentioned the word scientism. He stopped me in mid-conversation and said, please don't ever say that word again. Because the implications of it, that it has become a belief system. It has become a religion. If you are straying from the scientific method, or you're accepting answers from fields that are not based in the scientific method, then you are literally following a belief system. And then you throw in the authority complexes of us just believing the white coats. Oh, there's much smarter men than I in higher fields, so I'll just believe what they tell me instead. Personally, I think that's folly. I think that we should know why we believe things. We should know as best as we can, and I think that we should try to believe as little as possible. We should figure this stuff out for ourselves. I don't care how advanced these things are. I mean, after all, we have a lot of people looking into cosmology and astronomy and the world around us, and we're mostly laymen in a large regard. So I think that we have every right to do this. And there's this, from the early 1900s, there's been this move towards scientism, this belief that science is the only way to determine the world around us. And C.S. Lewis was also very big against this notion of scientism. He wrote about it extensively, and there's a lot to be said from his work. Let me see which one it was called. He actually did 3 works, but I'll mention that towards the end. I gotta look it up again. But he coined the term scientism, and he was really worried about this issue of this scientist dictatorship that might come forward, where people just believe, if it's science tested or doctor approved, the white coats tell you it's fine, then it must be true. I think we're all kind of waking up to that, and we're questioning things. So to get back to things, let's take a look at the scientific method and understand how this distinction can be made, because yeah, I think it's very simple. If you understand what the scientific method is, you can apply this understanding to every one of these fields of science and determine if it is valid science or not. So with that, let's go ahead and kick it over to you, John, and let's get through the presentation. And then if I have any questions, I'll jump in and ask you as we go along.
Hey, Cathexis, I agree with most of the things that you said. There's another issue that I think is really prevalent today, and it sows discord. And what it is into, and it's real easy, miscommunication. We don't listen to each other, and terms aren't defined. I'm a big fan of the Socratic method. You have to define terms. Everyone has to be on the same sheet of music when discussing a subject. Because if I'm talking about bananas and you're thinking the banana's an orange, then we're going to have some discord and some confusion and frustration when we get to, well, what is a banana? I mean, it sounds silly, but it really boils down to that, I feel. I think, I'm in a lot of conversations with people, and there's a lot of miscommunication, and you can tell people get frustrated real easy. And I think it boils down, say for, the agendas, willful ignorance, and just plain ignorance. I think that's the biggest problem. I don't know. What do you think?
Well, yeah, willful ignorance for sure. But outside of that willful ignorance, just as you said, there's a lot of people who just don't understand what these things are, especially with a term like science and the way that we've been raised in this current society. It's just, the term is amorphous, and it shouldn't be. It should mean something very,
Exactly.
very clearly understood. And yeah, that's where the miscommunications start, I think.
Yeah, and it is, but it seems that it's been obfuscated. For some reason, I don't want to get into motives. I don't understand most of what you learn in science, real hardcore science. Most of the stuff I'm going to talk about today is 5th grade level science.
Yeah. Yeah.
So it seems
yeah,
that
but we can always use
this.
a refresher. There's a lot of people who didn't learn it, though. I remember back in my 5th grade class, there was plenty of people jumping around waiting for recess, and they didn't care about this stuff. Teachers just moved you right through,
That's true. I agree. If you don't use it, you lose it. There's no doubt about it. So that's a player too. Yeah. Okay, so let's get into it.
For sure, man.
Well, let's go ahead and, like I said, go ahead and define it. So basically, science is any system of knowledge that is concerned with the physical world and its phenomena and entails unbiased observations, and this is why I underlined and highlighted this: systematic experimentation. To be science, you have to be able to test it. So testing. Without testing, it's not science. The final arbiter of truth in science is experiment, period. That's it. If you're not doing any experiments, and we're going to get into what that entails precisely, then you're not doing science. It's just that simple. From Professor Schenker, he's the chair of physics at Yale. The only way things change in physics is experiments. Everything is based on experiment. That's the only way we change our mind, right?
Yes.
From the University of Rochester, the physics department. This is one of the best short treatises on science and the scientific method. The scientific method requires that a hypothesis be ruled out or modified if its predictions are clearly and repeatedly incompatible with experimental tests. Further, no matter how elegant a theory is, its predictions must agree with experimental results, there's that experiment again, if we are to believe that it is a valid description of nature. In physics, as in every experimental science, which is redundant, by the way,
Yeah.
experiment is supreme, and experimental verification of hypothetical predictions is absolutely necessary. Now, I don't know what absolutely necessary means to you, but to me it means you gotta do it.
Yes, sir.
If you don't, then it's not science. Again, what differentiates, science from badminton or ecology or finance? Well, the scientific method distinguishes science from other forms of explanation. Environment for what? Experimentation.
Yes,
Once you get
sir.
in the gist of this, you gotta do experiments. Now we're on the one that drives me absolutely, and I hear it no matter. Science isn't a result. It's merely a method of inquiry. It's an important method, but that's all it is, a method of inquiry. Science doesn't say, run, jump, point to, swim, do the hokey pokey, or anything else.
And this is the biggest issue. This is what it is. You hear so many people who are even aware that this is the way it is, who speak of science as some monolith. And, there are people in this community who do it a lot, but there are just as many people who are with the mainstream, actually, if not more, who constantly speak of science as some monolith. Science says this, science says that. And this is where that belief system comes into play, I think, in the way I look at it, is because they've treated it as some ultimate authority, because they think it's a pure system that will always be able to self-correct because of its method, at least. But we'll get into that a little bit later. But yes,
well,
thank you.
My question is, why would it need to correct? If it needs to correct, then it was incorrect to begin with.
Well, they make mistakes. I mean, sure. But my larger point is that there's fraud and agenda and dogma.
Oh, sure.
And all of these within the institutions of science. And this is one of the hardest things I think it is for people to wrap their head around. When a person first gets into this alternative cosmology, like trying to understand, if there's something else going on here, the first thing they run into is that problem of, well, first of all, they're saying science says, and two, they have this belief in the institution, this uncorruptible institution in their mind. I suffered from it myself. I truly did. The longest time, I was a scientism believer. And I think that it's very important to make the distinctions as we are, because not enough people are talking like this, and I think that this is necessary to go forward. So I appreciate this, John.
You're welcome. All right, let's continue. Science is about testing variables. So here's the scientific method. It's very easy. The steps are clear, cut, concise. You observe a phenomenon, you do a literature review, construct a hypothesis, you test an experiment, analyze data, you validate or invalidate the hypothesis, and you report the results. Now, most of these, as you can see, are logistical in nature. And I just wanted to isolate the three most important ones and where we head off the rails. So, the scientific method was developed to rid the world of myths, consensus, votes, majority, opinions, loudest voices. In other words, rid the conclusions of the subjective by establishing a method that solely focuses on the empirical, the objective. And here's another term that gets thrown around where people don't know what it means. Empirical simply means observable, testable, repeatable, and falsifiable. That if you could encapsulate the scientific method into terms, That would be it right there. Because as you can see, that takes care of everything in your steps for the most part, except the logistical concerns. So observable, testable, repeatable, and falsifiable. Got to be that, or it's a just so story. So let's go into step one. So observe a phenomenon. It's just what it says. Observation.
Hold on, John. So sorry. Can you hear me?
Sure. Yeah, I got
it looks like I just lost my Wi-Fi connection at my house, and it's rebooting right now, but the main account dropped. I have to get it back in within 5 minutes, or we're going to lose the entire stream. So I just wanted to give you a heads up, and anybody listening, if we go down fully, we'll be right back within 10 minutes, but it looks like my internet connection has gone down. So you can just give us a moment. Hopefully we can work through this. We should be on air still right now, at least.
I haven't checked it.
Well, it's connecting right now. Sorry for the pause, everybody. Hopefully we don't lose the stream. Usually they give you a 5-minute window, but yeah, we just had a rainstorm come through, and it never does this. I think we just get DOS by some agency.
You are breaking. You are breaking up.
Yeah, hold on 1 second. Hopefully we can get this. Okay. Shoot. Connected. Okay. Can you hear me?
Yeah.
Okay, reconnect. 1 second. One second.
Take your time.
Check the stream. Okay, I think we're still going. Thank you, everybody, for your patience. I think we're back up and safe. So we'll continue. Sorry about that, John.
No, that's no problem. Okay. Like I said, we'll go through each of those 3 steps, the important ones that I wanted to isolate and emphasize. So, observe a phenomenon. It's just what it says. Observation and description of a phenomena or a group of phenomena is step 1. From Geosociety, the first process in the scientific method involves the observation of a phenomenon, event, or a problem. You have to observe something so you can ask the question. From Niels Bohr, no phenomenon is a phenomenon unless it is an observed phenomenon. See, this is where most head off the rails. The first step in the scientific method is apparently somewhat confusing. It's not make an observation or ask a question or conjure a phenomenon. It's observe a phenomenon. It's an action that you observe that must be based in reality so as to afford you the ability to test it. It's also not just observe.
Sorry, we had an issue with this the other day when we were talking in debates. I do want to make clear the word phenomenon means to appear or be manifest. So if you go back to the original there, it implies an action, a manifestation, something that's appearing. So I know we had some issues with the language the other day, but I don't think you can really quibble over something like that as they
right.
did.
Right. And there is some confusion with the nouns, because what I was referring to, like I'm saying here, it's also not just observed as in observed concrete nouns. Those are rocks, fossils, trees.
Those are not
those
phenomenons.
are concrete.
Yeah, those are not phenomenons.
Right, they're concrete. Yeah. They're concrete nouns. Right.
Gotcha.
Now, you have to observe a phenomenon. It could be an abstract noun like scurvy. So you can't touch or feel scurvy. It has certain characteristics or manifestations of the noun, if you understand what I'm saying. And we'll get to that here in a couple minutes. It'll become more clear. It's an action that you observe. And like I said, it has to be repeatable. It can't be a one-off event. If so, how can you test it? You could just observe something. It's a one-off event, like in astronomy. You can't test anything. You can't cause and effect it. You can make up a story about the cause, but that's about it. Try an example. if you try and circumvent the scientific method and hypothesize observations of concrete nouns, or make just an observation, or ask a question, this is what you're reduced to. And I just looked outside in my backyard. Example one, I observe a tree. That's a concrete noun. So what's the hypothesis? How did this tree form? Well, that's invalid. It's not observed. I just observed the tree. It's just sitting there in my backyard. So, or what circumstances led to this tree growing in my backyard? Well, I don't know. I moved in 2007. It was kind of small then. It's kind of big right now. So I don't know that. So it's invalid. It's not observed. The tree formed by evolution. Well, that's invalid. It's not observed. And you have a begging the question fallacy in the hypothesis. Evolution. You haven't validated that yet. You haven't even defined it. So these are not valid scientific hypotheses anyway, but I wanted to put them or speak to these because these are typical in what you usually hear, or something to that effect.
Sure.
Okay, go ahead.
Oh no, I was agreeing with you. Yeah.
Okay. Okay, so remember, testing. What's the test? So first you got to actually post the formal scientific hypothesis, and then please elucidate, and we're going to get into these, the independent variable and the dependent variable. We're going to talk about those in a few minutes. So you make a set of observations, then you hypothesize an explanation which accounts for all your observations. Okay, so let's hypothesize an explanation which accounts for all the observations. So with my tree back here, since we just observed the tree, how do we account for all the observations? This is your only recourse. Each and every time you just make an observation of concrete nouns. Every single time, no matter what it is. Your hypothesis from the train wreck observation. In the daytime, open your eyelids, then billions of bits of data hit the retina, which the photoreceptors have to encode and decode, then send to the visual cortex to decode. That's symbolic logic. That's another subject. Voila, a tree. So the independent variable here, or the cause here, is your eyelids. See, that doesn't make any sense.
Yeah.
Your eyelids didn't cause the tree. So it's a train wreck. And it could be a tree, it could be fossils, it could be rocks, it doesn't matter. If it's a concrete noun, forget about it. You're done. You can't get past the first step.
And so just quickly, let me ask, did you add this to the presentation after our conversations the other day?
I added, yeah, because
the word phenomenon should be enough, but people are, these scientism believers want to harp on every little thing to make their don't mind me. I think that's great that you added this.
It's an important point. No, I just added because I said nouns. I was thinking concrete nouns, but I didn't add it in there. So I want to be specific and in detail. So I just added concrete nouns. There you go.
Gotcha.
That's what I mean by it.
And that's absolutely relevant. So
yeah,
I can appreciate that.
All right, so we're going to spend some time here because this one gets taken to the woodshed and bludgeoned incessantly. It's just a simple hypothesis. I get in so many arguments over what this is. It's real simple. A scientific hypothesis is just your experiment statement. You need it to do the experiment. It's what your experiment is. It expresses a testable, proposed cause and effect relationship. I'm going to keep on repeating this because it's so important. Cause and effect. It's all cause and effect with hypotheses. The cause and effect relationship is the phenomena that was observed in step one. Whatever phenomena you observe, you want to identify, isolate the cause. That leads to knowledge. Correct? And we're going to go over a few examples here in a few minutes.
All right.
It's a classic if this, then that motif. So this says it really well. It's from Colorado State University. Scientific hypothesis is a special kind of a prediction that forecasts how the independent variable will affect the dependent variable. That's it.
Yeah.
A hypothesis from chemistry about a educated guess based on observation. It's a prediction of what? Cause and effect.
I didn't know you were being rhetorical.
Here we go
Yes,
again.
cause and effect.
Cause, I want to stress this because it's so important. The
It
scientific method from Drexel University. The scientific method is hypothesis driven. One makes an educated guess to explain a cause and effect relationship. From Lowell, C, becoming a successful scientist from Cambridge. A scientific hypothesis is based on cause and effect reasoning. A scientific hypothesis does not merely state X and Y may be related or correlated, in other words, but explains why they are related. Does everyone,
Gotcha.
are
Yes.
we on the same page with this?
That is correct.
From California State University, formalized hypotheses contain two variables. We've heard these before. One is the independent, and the other is the dependent. The independent is your cause. The dependent is the effect or your prediction. The independent variable is the one you, the scientist, control, and the dependent variable is the one that you observe and then measure the results. Notice there are two parts to a formalized hypothesis. The if portion contains the testable proposed relationship, and the then portion is the prediction of the expected results from an experiment. An acceptable hypothesis contains both aspects, not just the prediction portion. We're not playing Jimmy the Greek here. Every scientific prediction is a consequent of its necessary antecedent. And its necessary antecedent is the independent variable. Any questions on that?
Nope, crystal clear.
So hypothesis, again, is elucidating cause and effect. The cause is the independent variable. The effect is the dependent variable. So
Gotcha.
let's use the Socratic method. What an independent variable is. From the University of North Carolina, an independent variable is the presumed cause, whereas the dependent variable is the presumed effect. The independent variable is the core of the experiment and is isolated and manipulated by the researcher. The dependent variable is the measurable outcome of this manipulation, the results of the experimental design. So question, if you don't have an independent variable, do you have an experiment?
Nope.
Nope, because it's the core of it.
Yep.
From the University of North Carolina, again, in an experiment, the independent variable is the variable that is varied or manipulated by the researcher. And the dependent variable is the response that is measured.
And I will say that
From Penn State University.
we're definitely stressing upon this because it comes into effect much later when we're talking about what real science is and what scientism is.
Yes.
So
yes, I'm stressing it because this is a bone of contention with people. They say independent variable and they start laughing.
Mm-hmm.
And to me, I can't understand that because that's tantamount to a carpenter showing up at your door and you giving him a framing square and he starts laughing at it.
Yeah.
That's what it's tantamount to. So I don't know. So I'm going through here. I'm establishing what this is. This is. I don't want to say basic, but you have to know this to pass 5th grade general science. If you don't know what an independent variable is, then your parents paid the science teacher off.
Yeah, and I think that most of this stuff socially, especially if somebody's not in these fields, this stuff is just lost in the mix, lost in translation even, and that's the biggest thing we're up against. We have, especially when we're out here debating these topics and trying to discuss these topics with people, we've come from a certain position of wanting to learn topics that the layman doesn't necessarily look after, And when we go and discuss it with other people who consider themselves smart, they'll end up not knowing the most basic thing, which we're going over right now. So I think putting this out here like this, getting a clear understanding of what we're talking about is helpful. So let's move on.
Okay, I'm going to stress it just a couple more times, and then I'm going to leave this one alone. The independent or manipulated variable, the variable that is changed by the scientist, what the investigator is testing. Colorado State. All right. We already went over California State right here. We already did that one above. The variable that is manipulated or changed is known as the independent variable. From South Alabama, an independent variable is a variable that is presumed to cause a change in another variable. In experimental research, the independent variable is a variable that is manipulated by the researcher. I think we're getting it. Okay, from the National Science Teachers Association. An independent variable is the variable that is varied or manipulated during an experiment. Okay, is there any questions?
No, sir.
Hopefully I can't do much more. Maybe I can go get it notarized.
Well, it's like I said, it's definitely necessary to stress, especially as we move forward in making these designations. So
yeah, I could put another 80 more, but I think everyone's got it now.
Mm-hmm.
Okay, so let's review a couple of examples. We're going to go through the process. So we're going to observe a phenomenon. Okay, let's say we're back in the day. Sailors appear crippled after long sea journeys. They've got poor wound healing. They got bleeding gums. They have rashes. So that's a phenomenon. It's called scurvy. There could be a number of possible causes for it, but for brevity, we finally realize it's related to diet. So we construct a hypothesis. So if vitamin C intake is crucial to collagen integrity, and this is in humans, then eliminating vitamin C intake in humans will cause scurvy. You see, I have my if, and then I have, this is a valid scientific hypothesis. This is a testable statement. And what I like to do with people to help them understand this is I always say, go ahead and post a hypothesis. And I always start off, what is your dependent variable? That is to say, what is the effect? What are you predicting is going to happen in this experiment? So what's going to happen in this experiment, we already know from the phenomena, is scurvy. Now we want to know what that causes. The independent variable in my hypothesis above is obviously vitamin C intake. So guess what I'm going to do? I'm going to take a population of subjects. I'm going to limit their vitamin C intake, and then I'm going to observe what happens. So I conduct the experiment, and voila. This is very important. If no effect, then try another independent variable. They're endless. Vitamin A, folate, B6, etc.
Sure.
It doesn't have to be even involved with diet. Bear in mind, and this is very important, if you try a variable with no effect, your inquiry and your experiment is not a failure. You've just eliminated a possible cause. That's very important. So example 2, observe another phenomenon. So we have a population of healthy type 1 diabetics who apparently a certain percentage of them are suffering from diabetic ketoacidosis. And this is a very serious condition. It's a life and death condition. So what do? Hypothesis. Given otherwise healthy type 1 diabetes patients, the lack of insulin on board will lead to diabetic ketoacidosis. And again, what did I say? I asked them, what is their prediction in this experiment? And obviously, their prediction is the endpoint is diabetic ketoacidosis. Now, what is causing that? The independent variable is, and that's the insulin or the lack of. So what I do is I take a population of otherwise healthy type 1 diabetes patients. Obviously, we're getting into ethics and morality here with the lack of
Sure.
insulin, because we already know what's going to happen here.
Yeah.
So, but for demonstration purposes, this is very good. It's simple, and it should limit the confusion. It's just this simple. It's always an independent and dependent variable. You gotta have both. All right, here's the next canard. Predictions. You'll hear ad nauseum, science is science because it can predict a reflect, right? Well, there's a big difference between scientific predictions and Gene Dixon, Edgar Casey, Nostradamus, Jimmy the Greek, and Carnival Tent predictions. That is, scientific predictions, as I said before, are the consequent of the necessary antecedent, independent variables. Again, scientific hypothesis what? A special kind of a prediction that forecasts how the independent variable will affect the dependent variable. That is, if you don't have an independent, then you don't have a prediction, or your prediction is in the Nostradamus category. And again, we already went over this. There's two parts, not only the prediction portion.
Well, let me just have a quick question about that word prediction, because
Sure.
One thing we hear in this realm of, the things that we look at, alternative cosmology and whatnot, the heliocentric model predicts things. You hear that phrase touted around often. Is that something that varies from the scientific method prediction that you're describing there?
Yes, because you don't have an independent variable. That sort of prediction is the consequent of observing patterns and regularities. See, the Babylonians at 800 BC were already, quote unquote, predicting lunar eclipses, right?
Yeah.
They were just taking series of observations. They were just observing patterns and regularities. That's all they were doing. That's not a scientific prediction. You're just observing patterns and regularities.
So when they say the heliocentric model predicts things accurately, well, it just happens to, because it's a system that repeats. They understand the repetition, and they're able to demonstrate that. And then we'll get into what model means here quite soon.
Yes, we will.
But let's go ahead and nail down the whole predictions aspect.
So examples of predictions without viable independent variables. Here's three. Let me go with two. We didn't want to talk about this one, so let me take this one out of here. If the Big Bang is true, then we will observe galaxies moving apart. There's a prediction without an independent variable. Why? Because what is an independent variable? It's something that you manipulate. Can you manipulate the Big Bang? I don't think so. If evolution is true, then we observe biodiversity. Yeah, that's not a hypothesis. That's not anything. I'll give you another one. If invisible fire-breathing dragons exist, then we will observe burn and scorch marks on garage walls. That is these are all in the same category. So what are these? Well, they're not scientific hypotheses. Guess what they are? They're textbook fallacies. They're affirming the consequent formal logical fallacies to be precise. This form: if P, then Q, Q, therefore P. The logical fallacy is that P doesn't necessarily follow from Q. Example: if evolution is true, P, then you can insert any Darwinian grab bag post hoc observations, fossils, homology, similarity, genetic variation, Q. Well, we observed these post hoc observations, Q. Therefore, evolution is true.
And you hear that one a lot. People are like, but the fossil record.
Exactly.
Yeah.
Right?
Yeah.
And most people see it sounds good. It sounds like it's valid. But once you start digging into it, It's a fallacy. And here is the fallacy. If I eat a whole pizza, P, I would feel very full, Q. I feel very full, Q. Therefore, I have just eaten a whole pizza, therefore P. Well,
Yeah.
couldn't I have eaten a 20-ounce ribeye with fries and been full? Yeah. So you have to prove, validate the existence and the veracity of the antecedent first. Then, most importantly, isolate the antecedent or independent variable in experiments to verify it, and it alone produces the specific effect or the prediction. Okay. Because I think everyone understands that. There's some sleight of hand with this. You just have to practice recognizing these fallacies. They're easy because there's a lot of them out there, and they follow this form. If P, then Q, Q, therefore P. They're easy to pick at after a while. Just takes practice.
Yeah, I get you.
So, taking what we've just learned, let's do a little practical exercise. Are these valid scientific hypotheses? So, number one, if the Earth is a sphere, then ships traveling away from you will eventually disappear from view hull first. So, as I said before, an easy way to do it is to start with your dependent variable or your prediction. So, the dependent variable or the prediction here is what?
That ships disappear, yeah.
Ships disappear hull first. Okay, what is the cause of the ships disappearing hull first?
Well, a modern ball earther heliocentrist would say because the Earth's a sphere.
Yeah, here it is. The Earth is a sphere. That's your independent variable. But wait a second. The independent variable, as we discussed, is the core of the experiment. It's isolated and manipulated. Can anyone manipulate the Earth so as to test it and isolate, then validate it as the cause?
And honestly, I think it would be better explained as the cause is atmospheric conditions, swells, waves, angle of attack, and height of observer. Those are the variables that you could probably manipulate in some way in order to find this information out, but that's usually ignored.
But as this stands, is this a valid independent variable? No. No. This is a non sequitur because it's a textbook affirming the consequent formological fallacy like we just went over.
Mm-hmm.
Here's the next one. If the Earth is a spinning ball, then stars will appear to spin in contrary directions at the alleged poles, respectively. So again, what's our prediction? Stars spin in contrary directions at the poles. What is causing this? What is our independent variable here in this alleged hypothesis? The Earth is a spinning ball. Again,
John.
The independent variable for the experiment. It's isolated and manipulated. Can anyone manipulate the spin of the Earth so as to test it and isolate it, then validate it as the cause?
Well, it would have to be there first, but that's another topic.
Here we go again. This is a non sequitur because it's a textbook affirming the consequent formological fallacy.
Gotcha.
So I hope this is clear.
I think so. I think so. You've done a really good job putting it out there.
Okay, so here's the next canard. Theories. I can't tell you. I mean, everyone has a theory about everything.
Everybody's got a theory as to what scientific theories are. Is what it comes down to.
That's a good one. That's a good one.
And this is a big deal. You see this being quibbled about amongst people in this community. And funny enough, it seems to be the people who are defending scientism who don't really have a good grasp of what the distinctions are here. And so let's definitely break this down.
Isn't that funny?
Yeah. I don't want to put everybody under the bus, but I've seen it more often than you'd want to hope.
I see it. I hear it constant. I see it and hear it and read it. Literature, everywhere I go, it doesn't matter. People will just throw this term out. Theory.
Yeah. New theory says that the nebula in
Yep.
40,000 light years away is, yeah, I've
Yep.
seen this on the most
Nobel
nonsensical days.
Prize winners talking about theories. It's
Yeah.
equivocation fallacy. They're equivocating between a colloquial theory, which is merely abject speculation. That's all it is.
Yes.
And scientific theories. Things in science are defined precisely. Scientific theories explain the how and the why, the mechanism and the process. For example, germ theory. Scientific theories are the result of validated, confirmed scientific hypotheses that have been rigorously tested. I got 3 definitions here: chemistry about quarks to quasars, the physics lab up at the University of Rochester, and they basically all say the same thing. A scientific theory represents a hypothesis or a group of related hypotheses which has been confirmed through repeated experimental tests. That is, you can't have actual scientific theory without it already being validated and confirmed by experiment, or in other words, hypothesis tested.
Gotcha.
And you can't have math or equations for a scientific theory. It's tantamount to having a married bachelor.
And that's what leads me to this next question. The theory of gravitation. Okay, this is, and I make this distinction often. There is a distinction to be made between what we call gravity on this Earth, which is things falling at 9.832 meters per second, and what is causing it.
Exactly.
Now, what they claim is causing it, and we've gone over this, I believe, last time, so we won't go too deep, but there's 2 answers. You have the Newtonian, masses attracting masses, and then you have, of course, the Einsteinian, which is warping of space-time. Now, with the masses attracting masses, this is the theory of gravitation that they have. They have no way of truly testing masses attracting masses in the scale that they need.
He didn't even believe it.
He didn't. No, yeah, actually, in the end of his book, he said it was philosophically bankrupt to think that was a possibility.
He said it was absurd to even consider it.
Yes, absolutely. So
I don't know and besides, the scientific community, like we went over in the last presentation, they don't even follow Newtonian gravity. They follow Einsteinian gravity.
Well, here's what I find is they follow whatever suits them. You have some people who follow the Einsteinian, some people follow the Newtonian because it suits them at the moment. So so I just wanted to make that distinction. That's not technically a theory then. Theory of gravitation.
Both are falsified anyway. We already went over that.
Yeah, we did.
If they have any questions about gravity, just review your last video. That should settle matters.
Definitely. So let's go through.
Okay. You can't have math or equations for a scientific theory because they're married bachelors. Why? Mathematics at best merely describes, whereas real scientific theories explain the how and the why, the mechanism and the process. Like germ theory. Scientific theories are a result of validated, confirmed scientific hypotheses that have been rigorously tested, as opposed to scientific laws. Scientific laws describe the what or the is. See, the cause here is not applicable, and these are often expressed mathematically. For example, the second law of thermodynamics. See, with scientific laws, the cause or the mechanism or the how and the why is nonsensical. It's an invalid inquiry. It's just an is. For example, how or why does heat flow from hot to cold always? Well, we don't know, and we'll never know. All we know every single time, it just does and is. Ergo, a scientific law. That's why they're called the laws of thermodynamics and not the theories of thermodynamics.
That's a good way of making that clear.
Yeah, exactly. That's why. So scientific laws never become scientific theories or vice versa. Each are domain specific inherently.
Gotcha.
from the College of Science and Mathematics at Kennesaw State. A law describes what nature does. A theory explains how nature works. Are we clear on this?
Absolutely.
This is very important because a lot of people get confused about these two terms.
Yeah, I hear people say that theories turn into laws after certain, after certain, proofs occur with it. So that's a very good distinction to make.
Right. Cool. All right, let's get on to math because this is another canard. Listen, I'm not a math, a matheistic. I'm not. However, when you try to equivocate, and I don't even know how you equivocate two different words, math isn't science or physics, much like a tape measure isn't carpentry. One of the main reasons is they're different words. Math is immaterial, it's abstract, it's rigidly domain specific, and at best it merely describes. It explains exactly squat, niente, nothing. Conversely, actual scientists are in the business of explaining by validating or invalidating cause and effect relationships between independent and dependent variables via rigorous hypothesis testing. I found this, and I thank him for saying this. Somebody needed to. This is Professor Balakrishnan. He's the professor of physics at ITD Madras. I just can't make it any more clear. That's the whole point about physics. It's not mathematics. Are we clear on this? Let me give you an example why. According to mathematics, there's an infinite set of numbers between 0 and 1. That is, if I started at 0, I can never reach 1. However, whenever I type an I followed by a B with the same finger on my keyboard, I invariably pummel this nonsensical buffoonery every single time. We all do. There's somewhat of a difference between the abstract and physical reality.
Absolutely. And a lot of people say, there's a Red's rhetoric screamed to the top of his lungs, math is reality. Like it's like
really?
Quoted. Yeah. I've heard on numerous occasions these Scientism fanboys. They think math is reality.
Can you give me a jar of 5s?
A jar of 5s?
Yeah, I want some 5s.
Right. Yeah. The abstract ideas. Yeah.
Can you show one case in all of history where mathematics caused any phenomena?
Yeah, this is an important distinction to make.
No, because it's contrived. It's conjured. You'd have better chances resurrecting Alexander the Great's horse. Physics is physical. It's concrete. Mathematics is immaterial and abstract. Is there something wrong with this picture? Yeah, there is. Attempting to explain the physical immaterially and abstractly makes as much sense as suffering from poison ivy on the brain and scratching it by thinking of sandpaper. So I hope that solves things.
Absolutely. And that's one of the biggest things we see. Like I just mentioned, people think math is reality. They don't understand that it's a description of, and it's a language that could be used to describe things even further. So these theoretical astrophysicists might as well be sci-fi writers in my book, because they're extrapolating all of these maths based off of it just goes on. And the Big Bang is a mathematical construct. It is, and a lot of people don't know this. I mean, there were observations, I suppose, that led up to a certain point, but then the math had to, be extrapolated from there. But all of these guys, that's all they do. It's mathematical equations.
Did they observe the Big Bang?
No. I meant like they took modern observations and declared a theory and then extrapolated it. I'd have to look into the origins of I know Lemaitre created it, but I'm curious what led him to those ideas.
Yeah.
But
and what they do, how they do it, is they hide it behind all the equations.
Yes.
Because there's only a limited amount of people that can discern the mathematics. And like I said, mathematics doesn't cause anything. I can have, $1 million plus $1 million is $2 million. But you know what? I don't have $2 million. So
Yeah.
I can conjure anything and explain anything or describe anything in mathematics. It means nothing. What did Tesla say about this?
Oh, that's a fantastic quote. It says modern day scientists go off from equation to equation, and gosh, let me get it exactly. 1 second. Let's see.
Okay. I know he had something to say about it.
Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality.
Yeah, I'll tell you what, you can't say
That
it
sums
any
it
better
up.
than that. Yeah.
That sums it up, brother.
I give him a big thumbs up for that one. That's good. That's concise, clear, and right to the point.
And it's true, yeah. And this is the thing, is we do have a large amount of scientific illiteracism. Like, people are unaware of how, and that's really why I'm doing this show and bringing you on, and I'm going through this presentation, because, this needs to be understood. And I really hope we could reach a more mainstream audience, just for the simple reason that they need to be reminded, because they're operating with a belief system. And they think math is reality. They think theories can become laws. You know what I mean? There's just all of these fallacies that they operate with. And that's what gives them the green light to believe in scientism. It's these misunderstandings in what these institutions are supposed to be, or these philosophical understandings. Because that's all this is. The scientific method has its roots in materialism, in the axioms of materialism, which we'll get to that for sure down the road.
Oh, yeah.
But the scientific method is amazing, and it's very valuable, and it's gotten us very far in this world.
Sure.
So let's go ahead and get on to models here. I know we asked the question earlier, but this is
the models.
important.
I'm sure everyone's been exposed to this little fiasco.
Now, this has to do with even the heliocentric model, right? In this context?
All models. Every single model. Models. And here it is from, again, the physics lab at University of Rochester. The word model is reserved for situations when it is known that the hypothesis has at least limited validity. All right. So what they're doing is they're trying to straddle a fence here. But I'm going to go ahead and chop their little fence down. Allow me to translate. Pseudoscience. There is no such animal as a scientific hypothesis with limited validity. It's tantamount to a woman being a little pregnant. Are or you're not. The hypothesis is either validated or it's not. End of story, period. A model is conjured when the alleged hypothesis is untestable. That means there never was an actual scientific hypothesis to begin with.
Gotcha.
And this is never ending. This is all I hear. So what's your model? Listen, we got a model over here. What's your model?
Yeah. Where's your model? Our model predicts things. Where's your model?
Yeah. It predicts. Yeah. Models predict. Well, to predict takes sentience and intelligence. Is the model alive? So what's your model? Well, you don't have one. Therefore, ours is correct.
Yep. That's another fallacy.
I like this one. I like that one. That's a good one. So number one, we don't need one to debunk your model, and models are merely pseudoscience stand-ins for the lack of a hypothesis.
Yes, sir.
So there we go. I really, people start talking about models, I just want to go away.
And I've been saying this. I've been calling it a straw man attack, because first of all, they say that, well, you don't have a model, so therefore ours is correct, and that's a fallacy in itself. But what most people do is they'll construct this model of what they think these people are thinking, like what the geocentrists are thinking, or what flat earthers are thinking. And they'll have it in their mind while they're looking at this stuff through the heliocentric lens. And they'll see, this doesn't work on that. This doesn't work on that. Well, it's a straw man. They built up a false understanding, then declaring it to be your model, and then take it down themselves.
Yeah,
So
I've seen that. Yeah, I've seen that many times. Yeah.
yeah, it's
Yeah.
nonsense. It's not a proper way to debunk anything. It's invalid
Yeah.
as a debunk.
They're assuming a model, and the model
Yes.
is a train wreck to begin with. Now you pile the assumption on it.
Gotcha.
So, all right, our favorite subject, religion. Everyone talks about religion and religion this, religion that. Really? Well, what is a religion, basically? The quintessential tenet of a religion is belief without evidence. The object of that belief is irrelevant. Belief without evidence at its core. Allow me to introduce you to some. The Scientism religions. Here they are, folks. Paleontology, anthropology, archaeology, geology, evolutionary biology. Yeah, I'm still laughing. Theoretical physics, non-experimental. Astrophysics, astronomy, and cosmology. Crocheting is more scientific than these clowns combined. The first six pretenders, can't get to the first step of the scientific method. Observe a phenomenon. Why? Because they need a time machine. And when they provide their time machine, make, model, and serial number, then we can have a discussion. The final three masqueraders, these guys right here, they have no problem with the first step of the scientific method. None at all, because they can observe phenomena, right?
Mm-hmm.
Where their problem, how they masquerade, is they can't formulate scientific hypotheses because they lack what?
That independent variable.
Independent variables.
Yes, sir.
They can't manipulate anything. All they can do is observe something, then make up a story. It's called just so storytelling. You can't isolate, test, and validate their dependent variable or their prediction. That's hypothesis. That's science. It's a hard stop. And this is quite telling right here. Check this out. In 1543, the one that started all this mess. In the foreword on the Revolution of Heavenly Spheres, 1543, by Nicholas Copernicus, Andreas Osiander, in the foreword, so far as hypotheses are concerned, let no one expect anything certain from astronomy, which what? Cannot furnish it. Lest he accept as the truth ideas conceived for another purpose, and depart from this study a greater fool than when he entered it.
And I would love to add on the rest of that quote said, and the terrestrial motion of the earth was nothing more than a hypothesis, used only to explain phenomena, and it should not be taken as actual truth.
That's not even a hypothesis.
But that's what that was what the book had said.
Yeah,
and this is right there in the foreword. So
yeah, it's right in the
this
forward.
is something, I brought this up to several heliocentric friends of mine, and they're like, so what? That was 500 years ago. He was an idiot.
What?
Well, listen, they're like, he's an idiot. And I'm like, what are you talking about? Whole heliocentricity is based off of this man's ideas. Well, it was 500 years ago. They just get out of it.
That's an argument to age fallacy.
Yeah, absolutely. But and that's all they know mostly. Now, this is a very telling quote, especially the part where it says, which cannot furnish it, lest he accept as the truth ideas conceived for another purpose. That leads to a lot of other questions, really, if you think about it. But yeah, this is a fantastic quote.
Preconceived presuppositions or preconceived biases. Yep.
Yes, that's excellent.
So let me ask you a question. How can you have science without scientific hypotheses? I'm asking you, how can you have bananas without complex, simple carbohydrates, potassium, and B6?
You need all of the components.
Yep. Science without scientific hypotheses is tantamount to water without hydrogen, for goodness sakes. It's confirmed in a big way here. renowned cosmologist George Ellis. People need to be aware that there's a range of models, there we go with the models again, that could explain the observations. For instance, I can construct you a spherically symmetrical universe with the Earth at its center, and you cannot disprove it based on the observations. You can only exclude it on philosophical grounds. And he says, in my view, there's absolute. Really, George? What I want to bring into the open is the fact that we are using philosophical criteria in choosing our AHEM models.
Yes, sir.
A lot of cosmology tries to hide that. Really. Well,
so
what basically we got here is welcome to philosophy, aka religion. Only these orators have calculators. That's all. That's the only difference.
And they got white coats on. Makes people take them real serious when they put those on.
This is a pretty serious indictment right here.
It is, and I mean, this was said recently. I think it was in 2007 that Ellis said this in Space Magazine.
Did he come back with it again? I missed that.
Where was this? It says
this is 1995 in Thinking Globally and Acting Universally.
I would have to check. I could have sworn there was a recent statement about it as well, because and this goes back to what Hubble said too, that the spatial curvature issue where redshift gave him the whole lot, and we'll get into that much later, but where it gave him the notion that, well, it looks like everything's moving away from us from, at a certain speed, that's uniform. That would imply that we're at the center. And he said that it is absolutely intolerable for a favored location. And we should only accept it to say phenomenon, but we should do everything we can in order to reject that horror of a unique position.
Right.
He was screaming at the top of his lungs that we cannot have the notion of a geocentric idea. So this is one thing I try to get around to people's head, is that people, especially the heliocentrists that I talk to the most, they're living in a model. Like, their head is stuck in a model. They don't understand that they're just observations that are mathematically documented that allows for us to know how the clock works, essentially, the clock in the sky. They have it mapped out a specific way. And that's not necessarily reality. That's not what it necessarily looks like up there. But people are stuck in the model. When you tell them heliocentricity might not be how it is, they typically get very angry but our observations, and we can predict eclipses, and how would you say that? Well, it's because they're living in a model. And they can't understand that. And the reason why is because they haven't gone down this process that you and I are going through right now to show them what science is.
Yeah, because remember, and look how many times you said models and predictions, and they're not using them in the right context.
Yeah.
And this is a telling one right here. He said he can construct you one with the Earth at its center, and you cannot disprove it based on observations.
No, they match up.
Yeah, they both work. Yeah.
I think I saw another quote from him that says both the geocentric and the heliocentric coordinate system work equally well, and we're choosing it on philosophical terms. It might have been a paraphrase of that, but
yeah, that's exactly what he's saying basically here. Yeah.
Exactly.
So this is the last indictment. This comes right out and says it. It was in science, cosmology may look like a science, but it isn't a science. A basic tenet of science is that you can do repeatable experiments, and you can't do that in cosmology. Wow. I'd like to correct this and state you can't even do an experiment,
let alone repeatable. Yeah,
exactly.
No, that's fantastic. That's a very good, strong quote there. And this is what gets people tripped up, is because we've been raised in a system where we think these sciences, quote unquote, or science is so falsely called, I could probably say.
That's a good one.
Cosmology, astronomy, and there's much to gain by observations and understanding these systems, but it's not lowercase s hard-nosed science.
Exactly.
And there's a distinction Yeah, and this
Yeah.
is the reason why I'm bringing you on and doing the show. A distinction has to be made because the lines have been blurred and they're playing into that. Mainstream pop science, especially, is just bleeding it all together, trying to
Yeah.
make this. It almost feels like some type of scientific dictatorship that they're trying to
Yeah,
put
but they're
together.
putting it under science. They're putting it under the umbrella of science. The pseudoscience pretenders, these guys up here, they're putting these under science by mere fiat.
Mm-hmm.
And using the equivocation fallacy with science, they can fit anything they want now underneath that umbrella.
Yeah.
And we're going to get to that here in 1 second.
All right.
Go ahead. Do you want to finish up on that?
Go ahead. That's perfect.
Here's the game the pseudoscience priests are playing. That's what I call them.
Nice.
They're pseudoscience priests, the ones that I identified above.
Perfect.
Example, let's go back to our phenomenon. The sailors appear crippled, bleeding gums, tooth loss, the scurvy deal. These are the plausible explanations. Let's say we never seen scurvy before. We just observed all these sailors going out on long trips. They come back and they're a train wreck. They have all these symptoms up here. Okay?
Yes.
So the plausible explanations, because this is a phenomenon. These are phenomena. Plausible explanation. Prolonged exposure to seawater, inhalation of aerosol seagull droppings, prolonged exposure to swabbing the deck cleaning solution, prolonged rolling and pitching of the ship, poor air quality, especially below deck, caused by smoke from candles, tobacco, mold, mildew, vapors from tar and waste in the bilges, hydrogen and carbonic acid gases from the ventilation system. What about what we don't know?
Right.
These are just what potentially they could be.
Mm-hmm.
So what do we do? Do we do A? Do we pull a bevy of current scientists and roll what most think it is, then call it science? Or B, do we test every possible cause? Guess what these are up here? All of them are independent variables.
Yes, sir.
They're causes. So, do we test every possible cause, read independent variable, and validate the effect, the dependent variable or the prediction scurvy? This is called science. Today's science, which is religion, like we just went over, roll with the pole A, because they are unable to validate and confirm anything by experiment. So what they do is they pick one and roll with what because it works, right?
Yeah, I get you.
True. Number 4 could be true. Of course, you're not telling everybody about the other ones, but we already know there's other ones. I mean, you're not hiding anything. So they roll with the pole, and that's A, because they're unable to validate or confirm anything. Then they say, well, what's the problem? Since transistors work, therefore spinning balls, multiverses, dark matter, evolution, big bangs, billions of years, ad nauseum, are scientific facts.
Yeah.
Wake up! No!
I agree, sir.
No!
And this is what's caused the problem, is that this distinction has not been made. It has not. And I don't know if they're even teaching it in colleges anymore. Yeah,
they are in the actual sciences, in chemistry, biochemistry, actual physics, quantum mechanics.
So they are teaching those students this, but I mean, what are they telling you in an astronomy class or a cosmology class?
No, that's not science.
Well, I understand that, but what I'm saying is, what are they telling their people? Are they telling them it's science? Because socially, we have this. Everybody tends to behave as if those are sciences. In that regard.
Yeah. No, I guess they're telling them, or they have it in, above the ivory archway. Science, and you walk through it,
right?
And then you think it's science. I could put bananas up there.
So would you say that those are philosophy? How would you designate those fields?
Those are I categorize them as religions.
Yeah, I understand. Religion or pseudoscience, but I mean, there should be a technical term.
Yeah.
Is there not one?
Metaphysical, just so fairy tale storytellers.
Now, I do
That's
want
my
to make,
opinion, really. I don't
and
care what their motives are. I don't care how good their heart is. It's not science. Stop masquerading under the term and then telling us where we live and pretend that it's science, because it's not.
I understand. Yeah, and I mean, I feel very similarly, yet I do make the distinction because I do feel like there's valuable things that can come from thinking along those lines. As long as they are honest with themselves and honest with humanity about what it is that they're doing. It
But
is a
that's
what
not what
so
they're doing.
you're right. They are masquerading as real science. And
They're coming out and saying, well, this is the way it is, period. And then we're scientists, they got initials behind their names. And so that offers some kind of, I don't know how they do it, some kind of transfer of veracity, to assign veracity with the term science, which they're not. That's all they're using it for.
Yeah, you get letters behind your name, and you could say damn near anything, and people take it seriously.
Yeah,
and and I respect education. I absolutely do. I respect people understanding their field, but my respect is more placed in that box of the hard-nosed lowercase s sciences, as you mentioned, physics and biochemistry, and these other.
How many actual physicists? And when I say physicists, I'm talking quantum mechanic physicists, because quantum mechanics is all the physical laws fall under quantum mechanics. How many quantum mechanical physicists, how many biochemists have come out and gave you this nonsense? How many?
Well, not many. You actually don't hear much for them.
I don't know. They're not going to come out. They're definitely not coming out. Huh. No chance. No chance, because they know. They know better.
But that is an interesting point. These whole notions of what fills out the heliocentric model, which would be the dark matter, dark energy, the Big Bang, the billions of years, etc. Those are the ones we hear about the most.
Yep.
Socially, they're the ones that fill up pop science, reporting or whatever.
And that's what fills up the textbooks.
Yeah. Yeah, I've seen it.
The nebular hypothesis train wreck. We're going to get to that. We're going to get to the CMB train wreck. I'm going to enjoy that one. Sorry, I may be a little bit twisted, but that has to be next to evolution. I didn't think anything could trump the nonsensical buffoonery of evolution. I really didn't. And I'm telling you what, that CMB,
the cosmic microwave background,
it's running a close second.
Yeah, it is. And if just to let everybody know, if you go out, watch the movie The Principle, does an excellent breakdown and rundown of the CMB, cosmic microwave background, and there's a ton of information. They call it the axis of evil. Modern cosmologists call it the axis of evil because what it's pointing to is a geocentric favored location. In their mind, they have to escape the horror. So what they did was, it came back, it gave them that result after one test, and they paid the money to do another.
They got it from WMAP. They got it from WMAP, and then they confirmed it with Planck.
Yeah, and then they couldn't believe it, so they sent another one up.
Yeah.
So these people worked very hard to try to get a particular result from that. But honestly, we could even put that in suspicion too, because I don't think these pieces of equipment are getting. How far away was it? 1,000 miles.
Okay. You hit on something very important, and we're going to get to that. When we go over to CMB, go ahead and bring that back up, because that's an important point. Because I don't know what the heck they're doing. I really don't, because it doesn't wait. Let's just hold off on that till I bring up that presentation.
Yeah, we'll do a full presentation. We might even do that soon, because it's really what I'm trying to focus on is more about cosmology and understanding it.
Yes, I know. Yeah.
And this I keep saying that this is just an important thing to understand, this whole what science is and what science isn't. And, people need to be more skeptical in their life. They need to, you find all these people who say they're skeptics, oh, I'm a skeptic, atheist, rational atheist, skeptic. But really, all they do is they have their prepackaged answers on Rational Wiki, Metabunk, or Snopes.
Yeah,
And
metabunk.
yeah, and they've got their prepackaged answer on every conspiracy theory or every alternative idea that
Mick from
yeah,
Metabunk, huh? Yeah, we already
yeah,
went over
yeah.
that.
Well, so they have their prepackaged answers. They go there, but they're only skeptical against things that go against the mainstream. And that's not
I
a
don't
real
think that's
skeptic.
being skeptical.
It's not, and it's terrible. They've hijacked the word. You've got that guy Michael Schumer. I don't know if you've seen him. He runs
Oh,
Skeptic
Michael Shermer.
magazine.
Yeah, I'm aware of him.
Yeah, he runs Skeptic magazine,
Yeah,
and
I'm aware of him.
dude, what these guys end up being is mouthpieces they're propagandists for the institutions, the scientific institutions mainly, but even the government. If you
Their
look at
arguments
they're debunking conspiracy theories and whatnot, and they're wrong all the time. Like Snopes. Snopes got taken over I'd say about 10 years ago. They used to be like a legitimate website to go figure out if things were true or not. That was what their whole thing was, internet rumors and whatnot.
I've never
Now,
been there.
hey, don't go. Now, well, it's a lot of people. If I tell somebody an extraordinary thing, they're like, "Well, I'm going to go check that on Snopes," and they usually will. It's kind of a popular place for people to check this stuff, but they've gotten completely brought into the fold, completely. And any controversial thing, if any like conspiracy theory, they're completely on the side of the ruling elite. We'll put it that way. So but the point I'm trying to make is that the skeptics have hijacked the word. These people are not skeptics, and they are scientism believers.
Oh,
It's
right after the CMB, we're going to do one on atheism, correct?
yes, we're going to get into
Let's
that for sure.
let's fill up the seats. I got something
Well,
for you.
I'd like to work in rational materialism into that
Oh,
same conversation.
that is the conversation.
Yeah, exactly. Okay, I just wanted to clarify. So
Yeah.
in this scientism leads a lot into that. I mean, what
Yeah.
science is it's the axioms of naturalism or physicalism or rational materialism. It's all the same thing, but the axioms of those philosophical systems applied in a uniform way. Now, let me ask you a quick question. How long have we had the scientific method officially on the books?
Wow, that
Roughly.
rough. You're talking back. I don't know. I would probably say Francis Bacon and cohorts.
Okay, exactly. So we're talking about, what was that, 1600, 17? Okay.
15, 16, 1700s. It started,
So it became pretty uniform, though, would you say, in the 1700s?
it's not just one person. I think all started with Aristotle.
Well, sure. I mean, this is all, yeah. I
Yeah.
mean, you could go back with it. But what I mean is, to the point where our scientific method is now, we've had it in this same form for a good 200 years, from what I understand. The very simple process of observed phenomenon,
Yeah.
create a hypothesis, variable, and like
he
the
knew
way,
it.
yeah. So
He knew it.
oh yeah,
In 1543.
actually did. Well, I'm going to have to look into this a little further because I want to know how long we've had this exact system. Because I've talked to some people recently, when I tell them these things, they freak out on me, and they tell me that no, the scientific method is variable. We can change it as we get better at being a human. I'm serious.
Yeah, they need to change it because that's how they infiltrate or ride on their Trojan horse, their little just so stories. Because you have to change it. Because if you don't change it, you're screwed.
Yeah, and that's what they what they do every time I bring this topic up. But the scientific method has been there historically for several hundred years, and they haven't added or taken away from it. It's a very simple, mechanistic way of finding what's correct or not. It's not
Yeah.
necessarily something that will find truth either. A lot
It's
of people
logical.
think that, yeah, a lot of people think science equates truth, and it doesn't necessarily always. You know, if you look back historically on what we thought was right or real or the prevailing scientific theories of the day, of the past 500 years, we've been 90% wrong
But wait a
about most.
second. Wait a second. Were they actual scientific theories or were they just theories?
Well, I'm speaking generalities, but I'd have to go and check to make sure what I'm explaining here. But you know what I'm trying to say is there's a book that came out called "What If We're Wrong," that where this author decides to look back at the past 500 years. I'm sorry, look back currently, like at what we all believe now, with a lens of his history, so to speak.
Right.
You know, and what he points out in the book is we've been wrong about most things 90% of the time as humans. Like what the prevailing thought is at the time, it turns out we were wrong about it. But right now, in this moment, in modernity, nobody thinks we're wrong. I mean, like, you know, all the how many people do you see arguing about the merits of gravity, arguing about the merits of any of this stuff? Everybody's going along to get along, it seems.
See, the reason why they're wrong is because it was never validated to begin with.
Yeah.
It was never scientific. It didn't follow the scientific method. Listen, if you follow the scientific method and you repeat your experiments, let's go back up to insulin and diabetic ketoacidosis. Guess what? The lack of insulin causes diabetic ketoacidosis, brother. That is truth. It's absolutely true. There's about 5,000 other ones I got. If you follow the scientific method and stay within its constraints, you're going to be good to go. However, if you weasel your way out into just so fairy tale story land, guess what? The majority of those are going to be wrong because you haven't tested them. Testing. If you're not testing, you're not even in the galactic vicinity of science. You're not anywhere near it.
Yeah, I'm with you, man. I'm with you. Hopefully we can, you know, just continue to hit these points home. I'll tell you what, they really get mad when you say astronomy is pseudoscience. I'll tell you what.
Why would somebody get angry though? Why does the emotion need to come into it? Something either is or isn't. Period.
I agree. But what we're dealing with here are scientism believers who get triggered because they think they have a belief system that makes them believe they don't have a belief system. They think they're following the structure of logic and reason and rationality and science, when really they're just materialists. They are a religion within itself, and they don't even know the truth of the matter. What they're doing is following what the white coats have told them. Some people may have a gradient of understanding across other fields, but for the most part, they don't understand a damn thing about the fields that they claim to represent in a way that they're knowledgeable of.
Guess what the irony of the whole thing is? It's actual science that has debunked materialism.
And we'll definitely be getting into that down the road. When we get, yeah, of course.
Hey, I lost you. You still out there? Hey, folks, I think we lost Cathexis. Let's give him another minute, see if he can join in. Maybe he got another thunderstorm down there in Florida. You need to move out of there, man. I heard they were trying to secede from the Union anyway.
Oh, hey, I'm back. I got dropped. Yeah, I thought I got sniped.
Oh, you got sniped?
No, I'm kidding. I thought Rhetoric and Discourse sniped me because he's a scientism believer. I thought he had some magic powers. But anyways, what's that?
While you were gone, we were discovering the mysteries of Florida trying to secede from the Union.
Oh yeah, I think they've wanted to do that a couple times. But yeah, this is something that a lot of people. It was hard for me to get my head around. Is
Sure.
like religion can be other, like science can be religion, unfortunately. Well, scientism. Science itself is, of course, the construct of, like what we just explained. It's there. It's a method. Science isn't a monolith. It's not something in and of itself. It's a method. But you have what the scientism issue really is. Um, it's got people, man. There's a great gentleman named Rupert Sheldrake who has a TED talk that he did about the 10 dogmas of science. And they banned his TED talk. Literally. They removed it from the archives and their own site. And so you could see it on YouTube. But this was the TED talk that woke me up to all this. When I realized that big G has not always been a constant, that light speed has not always been a constant. They've changed over the years. And that's the thing, is that something is a constant, it's a constant. It shouldn't be variable in any way. It should have been what it was when they found it. But that aside, I don't get it all that. Evolution has become a dogma. And as we see, cosmology has become a dogma. Everybody's mind is living in a model concerning cosmology. And it's really frustrating because this is a paradigm to crack. It's so hard to get through to people because they're conscripted to a paradigm that they didn't even know they were conscripted to. And they're told that they're smart for believing it or knowing more about it. Especially when it comes to the heliocentric model, you might as well be recounting like the size of the Millennium Falcon or how many parsecs Kessel was. I mean, it is literally the same thing. It's a science fiction story that the world has just swallowed whole.
Yeah. Well, they keep you dumbed down. There's no doubt about that. I mean, as long as there's American Idol and cheese fries, keep them in the dark. Because Joe Coffey and Betty Breadmaker, they don't know this stuff. All they know is the periphery and what they're told. And you know what?
But this stuff affects philosophy heavily. This stuff affects, when you get the notion of a Big Bang cosmology that gives the billions of years necessary for evolution, and a common man who works really hard and does what he does in life, but who doesn't take the time to think about these, Big Bang cosmology and evolution will still be, in his mind, he will know that these are the prevailing scientific thoughts.
That's correct.
And it will affect his relationship within to himself.
Oh, there's no doubt. There's no doubt about that. That formulates your entire worldview.
Yeah.
Every situation that you come into, that is what you're working off of. Oh yeah, it has immense ramifications. Immense. In everything that you do.
Yeah, it does. It matters deeply. Your philosophy is dictated by your cosmology, and it's the billions of years that is. See, first came heliocentricity, then and even Nietzsche had said himself, when we know that famous quote where he says, "God is dead." Well, he goes on to say,
problem with him.
Well, he says God is dead, and what he goes on to say is, "We have killed him." And then in the next paragraph, it says, "We've killed God by pushing him out, by Copernicus putting the sun in the center of the system. We've pushed God to the edges of infinity." He blames.
Well, that's true.
It is. No. Nietzsche is actually pretty misunderstood, strangely. But if you go and do research on Copernicus and Nietzsche, he has several pages devoted to Copernicus, where he is declaring that it was Copernicus that changed everything, and now we're moving towards this godless nature. Now, that's not my whole argument for this. I believe that, I like, you hear a lot of people saying, oh, they might lie about, heliocentricity or geocentricity because it's hiding God. And you could simplify it that way. But I think it's way deeper than that. I mean, if you and I were raised in a system where they told us we were geocentric, where instead of saying heliocentric, they told us we were geocentric, the common man, the person just growing up in that system, would recognize their value. They would be more valuable to themselves, and life would be more valuable, because there is that favored location type mentality. It's built into the notion. So at the very least, they're hiding that issue.
I understand that. Sure.
Of course you do.
But I disagree. I disagree that the elephant in the room, it's obvious to me.
Yeah.
And it's definitely not you. These days, see, back then you could easily hide God with this, but you can't hide anymore, brothers. Can't hide them anymore, because I'm coming after you.
There you go. And we're
going to be dealing with genetics.
I also want to make
biochemistry, quantum mechanics.
Oh yeah, we're definitely going to go down the line, but I want to make a quick distinction, because having you on here, you are certainly very strong in your views upon this, and I understand why you take such a literal effect, a literal course with what is science and what isn't science.
Sure. And
I do want to make clear that I do value these other fields, the observational side of cosmology, of astronomy, but it needs to be said that they are not science in the way we should understand what science is. There's no scientific method to be had. So even though they may be associated with science, they are not. And I'm going to have to cut.
I'm going to have to cut them off. I'm sorry.
No, I understand. You trust me. I'm with you on that to a large degree. It's just these things do exist, and we've had them for ages, and they have given us certain informations. I think they should just simply be renamed and not designated as science.
I got a name.
I know you do. But I mean, you do see value in these fields, correct? I know there are a lot of erroneous BS in it, but there should be people at least, theorizing about cosmology or looking at stars and trying to, find the repetitions. And
I'd have to go on a case-by-case basis.
You can call it philosophy, maybe. I mean, at the very least.
I'd have to go case by case with not taking the whole disciplines, but inside interdisciplinary. See, they can't even make claims, though. That's where we get into problems. So I don't know. Like I said, I'd have to go case by case.
No, fair enough. You make a strong point. I just personally like to make the distinction, because I do think the fields are valuable, unless it's all erroneous, unless it's all absolute garbage. But I think there's still something we can learn, from each of those. So I just wanted to make that clear.
Okay.
But let's see what we have coming up. I think we'll do next. I think we should just dig right into cosmology next time. Actually, do the cosmic microwave background and show how this fits in. This will be the Scientism series. This is just the primer, guys. I want everybody to know that we were just breaking it down for posterity's sake, and so everybody can get an idea of what direction we're going to go with this. So in the future, we're going to speak about things a lot more specifically. But yeah, do you have anything you want to add today? I think we could wrap it up soon.
No, I think that's just about it. That's the end of my presentation for now. Unless somebody wants to bring up certain points about it, that we can come back and we can I can reply to anyone that has a retort. I don't know what you're going to do.
Well, sure. How about this? We'll put it out there for anybody in the chat to ask a question about what we may have talked about. Okay.
Well, let me stop screen sharing here and let me. I haven't been on the chat, or I haven't pulled it up yet. Let me.
Well, I'd like whatever is put up. I would like it just read first. That way, any viewers down the road will know that, you know what I mean? Like I sometimes I used to just talk directly to the chat, and when you go back and rewatch those videos, you have no idea what. So hopefully they got some good
Right.
questions, and then
Sure. Okay.
let me stop presenting you. So I'm going to give a huge shout out to everybody who came. It looks like we peaked at about 60 viewers this evening, and which is good. It was last minute. I'm going to start scheduling these. Yeah, we got 56 right now, and it looks like the chat has been actually not very trolly like it was last time. I guess the trolls aren't out in force. So if anybody would like, please, put out a question or a disagreement. I know that Rhetoric and Discourse was calling me names earlier and that's why I made that distinction, by the way. I made that distinction last night, and I made the distinction again today about astronomy being valuable, but it is not necessarily science, hard nose, lowercase s science. And I don't see what's the problem in that. Really? I mean, what's wrong with making a distinction like that? It's ridiculous.
Oh, I think they're calling you dishonest.
Yeah. These are the heliocentrist cultists, who are in a belief system that they don't know how to look outside of. So it's unfortunate because, I try to bridge the gap with everybody. I try to be as decent as possible to present different paradigms. I'm not saying one way or another when it comes to our cosmology or anything. I'm just asking specific questions that a lot of people aren't asking, I think. So people can say whatever they want. The majority of folks do tend to agree that I am honest, and I'm being more honest than a lot of people because I'm putting myself out there in a large regard. I have no agenda. I'm really just here to get people thinking, and that's really it. So,
Somebody said you're awesome, man.
Thanks, guys. Seriously, it's really great having everybody out with the support. So, any technical questions, any issues you want to take up? You say, like good old Captain over here, you got something that you'd like us to address? You saying that I'm bad names about me? That's the internet.
The name calling thing. Yeah, I remember that in 3rd grade.
Yeah.
Do that.
Yeah. Oh yeah. See. He's stuck in the belief that I'm full of shit. So far, I've not disproved that. Well, all I did tonight was we went over the scientific method. So if that makes me full of shit, then who knows what you think, honestly. Who cares?
Well, unless they have another scientific method.
Well, wait, we got Flat Earth Math who just joined. He missed the whole presentation.
Charles!
Good old Charles here. Maybe Charles has a good question for us to address. We just went over the scientific method.
I've got about 85 for him.
We'll have to do a show with Charles. I've already done one before where he came on for about 3 hours. We went over Boats Over the Horizon, and it went well for the most part. Charles is great. And he's super, like, he never gets, if he gets mad, he only becomes passive aggressive. That's about it. He never gets really nasty. He just, shout out to Mr. B, one of the best astronomers. Oh, wait, that makes him a pseudoscientist. Mr. B, you're a pseudoscientist. I'm just kidding.
Who's Mr. B?
Oh, he's a guy that we've known who used to hang around the chats a lot. He actually is a amateur astronomer. He's got like might as well be a professional. He's got like a $6,000 rig. It's crazy. And,
wow, that's pretty cool.
Well,
as long as he's not making any claims.
Well, no, actually, he stays pretty neutral. He just shows us the pictures, is what's pretty cool about it. Click here for Helio lies, he said. He's my favorite helio cultist nihilist. We'll put it that way. He likes that I make that joke. But yeah, we just have a lot of nice, decent folks out here in the chat, and we won't take up too much more of your time. We'll go ahead and close this down, and we'll get some things going next. Maybe we'll bring on a guest next time. Maybe Charles might want to join us. He could probably make a good argument against that, the next topic of cosmology. So yeah, we'll go ahead and shut it down. So John, thank you so much for joining. Honestly,
you're welcome. It was my pleasure, man.
Yeah, we're gonna have a really good series here, and hopefully this, I'm sure we're preaching to the choir in a large regard. Folks who are already tuned into this, they'd be the ones who appreciate a conversation like this. But I'm hoping we could be able to cross some bridges with this type of information and point out why scientism is not a good thing. Because it just isn't. If you're going to claim that you care about facts and logic, you should know that you're operating within a belief system, and that's contradictory. So anyways, yeah, thank you so much. Thank you for everybody who came out tonight, and keep a lookout. We'll have some more shows up here in the next couple days. Thank you, John. Take care, guys.